Hi, welcome to this short video that shows how to view DS402 can open objects as used by TwinCAT when commanding a Control Techniques drive. So the hardware that we're going to be using in this demonstration is a laptop. It's been loaded with Beckhoff TwinCAT. It's also been loaded with Control Techniques Connect software. We've then got an Ethernet connection that connects through to our Beckhoff hardware, which in this case is a Beckhoff IPC, but the steps that you'll see in this video are identical even if it's a controller or a PLC from Beckhoff. Next, there's a port that's been configured for EtherCAT connectivity, which is connected through to an SI EtherCAT, which is plugged into the drive that we'll be looking at in this demonstration, which is a Unidrive M700. Now, if you've got one of our dedicated servo products, such as Digitat's HD M753, this interface is built into the product. But what you'll find is the steps and information that you'll see in this video are identical for that particular drive and interface. So, quick overview just before we get going into the demonstration. Whenever you're working with Beckhoff, it's pretty likely that you're going to end up moving your axis with either an NC axis or a CNC axis, which is essentially an implementation of PLC Open. Okay, now the NC axis itself processes all of the position references or speed references that you input using function blocks like MC move velocity and calculates the resulting position, speed, acceleration rate, jerk, etc. And all of that ends up resolving in a real-time position reference and a control word which must be passed to the DS402 interface here on the drive. So there's a copy of all of those registers over in the Beckhoff hardware. Those then get transmitted over PDO or SDO over the copper through to the EtherCAT interface. Those messages get read and then the results get put into the correct memory areas for DS402 actually at the product, and then that then sends on a position reference to the drive, for example. Okay, but what you can see is that if you have any problems whilst sort of starting up, or you're trying to investigate because you're having kind of commissioning issues, it's very useful to be able to interrogate what's going on at the DS402 level outside of the NC axis level, so that you can see what's going on and potentially diagnose your application. So before we get into it, I just want to point out that there's a getting started guide that follows along with all of the videos in the TwinCAT series. It's linked in the description, and it's really there for people that don't want to take notes whilst watching the video, so that you're able to kind of make progress, or if you simply just prefer learning from a written document. It's free to download for anybody, and it's linked in the description. I'll just show you. We're in the how-to guide, so if I expand that and then go to how to view CAN objects, you can see here, this is the section of the document that follows along with this particular video. So what I'll point out is I've got a project, it's online, so ADS comms are working, and I've told the project where my target is, I've told the project to scan, I've found my EtherCAT interface, and I've found the drive. In this particular instance, I've got one of the motion interfaces running that we supply in an NC axis motion library from Control Techniques. Okay, not that this is important, but just to let you know what's going on at the TwinCAT level, let's say. Okay, the main thing is that ADS communications are up and running, so Connect is able to interrogate the product. Okay, so now what we're interested in looking at here is information in the DS402 layer. Now, in the case of Unidrive M700 in the diagram that we saw before, the EtherCAT interface has been fitted as an option. So if we want to look at the DS402 CAN object viewer, we have to click Options, slot 3, because that's where the option is fitted, and then we've got CAN Open Object Viewer. So if I click on that, that launches the viewer, and you can see that we've got a live view of all of the data going on there. Now, just to show, I've put in a Digitat's M753 here. It's not online or anything like that. I don't physically have one, but just to show how you get hold of it, because the EtherCAT interface is native to that particular drive, you would just click on EtherCAT v2 and then CAN Open Object Viewer to launch the exact same view for this particular target. Okay, But we'll go back to this drive for now and look at its object viewer. Now, what you can see over on the left here is the operation window. And the operation window tells us some useful information. So to start off with, it tells us that the operating mode of the DS402 interface is cyclic synchronous position. If you don't see cyclic position, it could be that you're homing, or it could be that just the interface hasn't started. But certainly, if your interface is running, you should always see cyclic synchronous position, because in this particular mode, this is the one that you need to use when you're linking to your NC axis, because as I said before, the output of your NC axis is a synchronous cyclic position, and this is the mode of DS402 that receives that synchronous cyclic position. Second thing that's of interest is that you've got the PDO accesses per second. So this is kind of useful information because it tells you if the number of messages per second that you've got matches what you expect your motion update rate to be. So in this case, it's 1,000 messages per second, so 1 message per millisecond. That's exactly what I expect because I've gone and set my project rates to 1 millisecond. Third thing that's interesting here is that you can also see if you've got FSOE modules or safety configured in your particular project, you can see the number of safety messages per second here. So all useful diagnostics, and you can see the operating state of the DS402 interface. So when you see op, that means it's operational and that it's running. Again, useful information. Then we move on to this section, which is the control word section. Okay, so this tells you all of the control word bits that have been set from the NC axis through into the DS402 interface, and similarly status word information coming back from the drive telling you what it's doing. Now what I'll point out is that, unless you're an expert on the DS402 layer or you've read the standard, it's quite difficult to interrogate which bits are supposed to be on at which time. However, to help you out in this document that I referred you to before, we've taken screenshots to show you which bits are supposed to be on at which time. So for example, this first section is the safe talk off input has not been is active. We've got 0 volts into the STO, therefore it's safe, let's say. And then the MC power block, which applies power to the particular axis, is set to false. So what you would expect for a working situation is this particular view. And as you progress through the different stages, so 24 volts being applied to STO but no MC power enable, or STO enable and MC power enable, you can see which bits are expected for that different situation. So you've got a way to be able to diagnose what's missing and therefore work out what might be going wrong with your application. So we'll get back to the viewer. Next we've got the target position and position actual value. So this is the feedback from the encoder on the product. This is the target position that we've been provided from the NC axis. So again, useful information. You might want to be able to see whether your particular encoder feedback is working, for example. So if I go and disable my drive, there you go. Can you see the position actual value is updating as I'm manually turning the motor by hand? So useful metrics at this level. Next thing, we got the object viewer. So this is all of the can open objects in the interface that are specified by the ESI file that you would have loaded in the TwinCAT environment. Okay, it's searchable, so it's quite nice. So an object that I use quite a bit is OX3005, which defines the behavior when you lose your cyclic data. So for example, if you go and pull the EtherCAT cable out of your interface, this is what it's going to do when that happens. So for example, cyclic loss action. So when you look at this, you get the index, you get all of the sub-indexes all nicely categorized for this particular object for you. Okay, you've got the live values, you've got the data type. So for example, if you wanted to go and set up a PDO link, it's important to know the data type. Or if you're trying to set up a startup list entry, you need to know the bit size in order to know how to specify the data to write to an object. So all useful stuff. The last thing that's worth pointing out is that for each of these objects, if you hover over this little grey square to the right, what you can see is you'll actually get some useful help on what those sub-indexes mean and what their values do. So for example, for the cyclic data loss action, quite often I'll put it into mode 2 as the value that we actually want it to go to, so that in the event of pulling the cable out, it'll trip the drive and stop the inverter. Okay, so this level of information is available for all of the objects that are specified in the ESI file. So not only is it interesting so that you can actually see what the values are, but actually you can kind of use it as a manual to be able to understand what you can do with it. Okay, hope you found that interesting. Thanks for watching.